Now, when models are released, they're typically released at a format or precision that's known as 32-bit or 16-bit. So let's say this is 16-bit, and we've got a high accuracy for this model. But the thing is, at the same time, this requires a large amount of RAM in order to store this and run this model. So the idea with Llama C++ and these Giga formats is that you can shrink the model down to a lower precision. So instead of 16 bits, we're going to store this as 4 bits. So we still have pretty similar capabilities and maybe a high degree of accuracy still. But instead of needing that huge amount of RAM, we only need, in this case, 25% of the hardware capabilities to run this model. So what's great is that we can use less hardware and we can run these models on smaller machines because of this model quantization, and that's what this process is called, going from high precision to low precision when we store the weights. So for example, you might see situations for these open models where they're released as, for example, deep, seek, and they're named in this format as well. So it would be something similar to quantize, Q for quantize, and then at 4-bit precision. And then we're also going to refer to a specific compression algorithm and type. So we're going to do underscore K and M. And I won't get too into the depths here, but this is just the variant that's tuned for quality that you'll typically see when you're searching open source models online. And that refers to the model compression that's being used in order to save perhaps 75% on hardware usage and capabilities needed to run the model